Hi everyone, my name is Anton, and today I want to tell you a little bit about a new interesting board, Radxa Dragon Q6A. Here it is. And of course I want to disclosure in the beginning that this board was provided for me by Radxa, so it can somehow affect to my opinion, but I will try to remain independent in this case. Speaking of this board, it's in my opinion pretty interesting board, and before I will touch how to run your neural networks on this board, how to inference, I need to discuss a few interesting and dependent moment. What is a Qualcomm board? Why is this important? How this board is looked from this Qualcomm perspective? How this Qualcomm stack working? What is the part that Radxa provide? What is the part that Qualcomm provide? How it's correlated? How to run your neural network, why it's more about Qualcomm. And in the end, I want to tell you like how you run your neural network. And in the end of this video, I will tell you a little bit more specifically about this Radxa board, its pluses, minuses, how you can compare it with different Qualcomm boards, and so on. So this video will be pretty long. If you want just check how to run your neural network, just find a specific part of this video. If you want to check my opinion about specifically this board, it's closer to the end. But I want to start like from the whole perspective. I want to start from Qualcomm because it's maybe the most interesting part about this camera. So why Qualcomm boards is super interesting and important. When we think about Qualcomm, for a long time it was more about mobile devices, how we want to run our neural networks on Android, how we want to communicate with this, and it was for a long time. Yes, there was some specific devices, like some robotic vendors created devices based on Qualcomm, but in general it was pretty rare, especially when we discuss mass market. Yes, maybe there was some super specific solutions, but in general most of the boards there was either like for mobile, either it was something super specific. But recently Qualcomm changed their view on their ecosystem, and there was like a lot of new devices, like edge devices. Of course, Qualcomm even released like PC for Windows. What we want to focus is some specific devices. And first devices like for mass market, where you really can like just take devices and run your neural network on it. It was maybe RB3 Gen 2, which was released 1.5 years ago. And after that, there was a variety of new devices. So it was a few devices from Thundercom, for example, like Rubik Pi 3. It was few devices like from Qualcomm with Thundercom, like this RB3, RB5 devices. And the last half of a year, maybe last year, there was a lot of announcements from a lot of major vendors about their own devices. For example, it's OAK 4D camera, it's some boards from Firefly, and of course this board from Radxa. Why it's important? And what doing this board interesting? In my opinion, this is important because Qualcomm really it's one of top 4 world companies that's creating their own CPUs, their own solution. And this company has a super big AI stack around. Of course, it's not such great as NVIDIA stack or Intel stack, but it's maybe better than AMD stack, in my opinion, it's maybe better than Huawei stack. So definitely this board can provide a lot of AI capabilities because specifically of this Qualcomm stack. These, like Qualcomm boards, they are pretty on high level of engineering. When you're working with NVIDIA, when you're working with Jetsons, it's always some problems with how to optimally connect cameras. Yes, maybe few last year, all these problems, they were solved, but even now I hear a lot of opinion from engineers that Jetson, it's not the best board where you can solve all like communication issues between camera and the main memory. And with Qualcomm, it's much more native because like much longer history of this edge device development. Of course, it was maybe from mobile part of view, but for Qualcomm, it was like their main expertise. The next important step is balance between this GPU, NPU, CPU, because in your smartphone, they actually balanced. It's already like the strong market that was developed for the last years. And of course, you want all this balance between and stack which allow you to run your neural network like simultaneously on a few devices, where you can run your one network on GPU, one network on NPU. All this balance is making Qualcomm one of the best solution when you need to run something on the edge. But Qualcomm previously was totally out of this market, and now they are going here. So this, my opinion, why Qualcomm boards, they are interesting. And I know a lot of feedback from different companies that few years ago they started creating their solution on Qualcomm because only with this Qualcomm engineering approach they could solve some like low power consumption solutions, some high frequency communication between the board and the cameras and so on. So what is making specifically this board is super interesting. In reality, there are only two boards with such capabilities in such price range. It's Rubik Pi from Thundercom and this Radxa board. They both cost around 100 USD. Radxa board is a little bit cheaper, and Radxa, of course, it's the only company that's providing such board without like as a Qualcomm main vendor, because Thundercom it's company that it's mainly oriented on Qualcomm, and here it's like independent company that created board on this Qualcomm, and it's like just a example where a different company took Qualcomm solutions and created a totally new board, which making it, in my opinion, interesting. There will be another super interesting Qualcomm board on my channel within a few weeks, I hope. So, but it's a board with different price range. But in this price range, with this cost, this board, it's definitely one of the most interesting. You may say, but I can take a different board, not a Qualcomm, in this price range with NPU chip. Yes, definitely. A lot of boards on my channel, you can check. But in my opinion, like this Qualcomm board is one of the fastest for this price. It has 12 tops of computational power, and it's definitely has one of the most mature stack among all other vendors. So with such performance, maybe only Huawei has pretty mature stack with all this bells and whistles around. It's super mature board from Qualcomm perspective. It's pretty cheap from other perspective. This is why specifically this board is interesting, in my opinion. What are minuses of Qualcomm? I will speak a little bit more about minuses of this board in the end, where I will speak about specifically this board. But now I want to focus on these Qualcomm minuses. So, first of all, it's pretty close ecosystem. Yes, last few years they open a lot. Previously it was super hard to have access even to something. Now it's much easier. They released the SDK, but it's a little bit strange. It's a big company, but they don't have any good open source repo. You need to download some binaries from their site. It's like a lot of documentation which a little bit messed up. Why it's like this? Because Qualcomm for a long time it was oriented on big vendors, where you just sign a direct contract with Qualcomm or with some or companies that is working with Qualcomm, and they provide you like information, they provide you support and so on. Once a few years ago, like 4 years ago, we had a contract with such company. We helped to develop them some models, and when I worked with them, I had access to Qualcomm stack, and definitely it was a good level of support, different level of documentation, and this is what the second minus of Qualcomm. You can, like, all their support oriented on a big business. And if you're a big business, if you're working directly with Qualcomm, you have totally different level of the support than if you're working with such board. It's a sad part. And of course, like the third minus of Qualcomm, in my opinion, it's overcomplicated. You will check a little bit later about all this stuff, but in my opinion, when you're working with Qualcomm, there is no one easy and straight way to do something. Even for quantization, you will have two different libraries. So let's move on the next step and speak about this AI stack around Qualcomm, how it's working, how it's integrated, and so on. First, the important part, that stack from Qualcomm, it's the same through the whole platform. So it's the same for mobile phones, it will be the same for this. But for such board, you can run your model with Python, at least. But if you work with C++, it will be the same stack for everything. This stack allows you to run almost anything like LLM models, classic models, quantized model, NPU, and so on and so on. And this quantization, in my opinion, is one of the most powerful part of this board, because Qualcomm, it's allow you not just, here is my calibration images, I want to calibrate this with the simplest algorithm. How, for example, Rockchip doing, how a lot of different vendors do it. No. Here you have a whole layer of different algorithms. With Qualcomm, you can do post-quantization with other round, batch norm folding, cross-layer equalization, bias correction, and so on and so on. Or you can just do quantization aware training within the same stack. It's look a lot like a Halo, where you also have such big and complex stack. But in my opinion, Qualcomm has even better and more complex stack around this quantization and so on. And also with Qualcomm, you can work with not only with int8 or FP16. You can work with a big variety of different formats. For example, it's also can work with weight 8 activation 16, like memory X board, which I already overview on my channel. This Qualcomm board, it's pretty unique how wide it in this support. But this wideness create you a lot of problems because you never know what you should use. And this is the main complex, as I mentioned previously. Because even for like, what is the name of the library that will work with this board? Few years ago, it was called SNPE. Later, it was QNN. Now it's QART. And you may think it's just a renaming of the same stack. No, it's totally different and complex, independent stack which can create your model, prepare this model for running, and run this model. So SNPE, Snapdragon Neural Processing Engine, it's oldest one, but still can be used. I worked specifically with this one like 4 years ago, and it was totally different. The next level, it's Qualcomm neural network. It's some model system which was used as a base for the new stack, but it's also independent, and you can find some guide about it. And the modern, it's like Qualcomm AI runtime. It's like pretty the same as like NVIDIA TensorRT, but NVIDIA TensorRT, it's more about inferencing, and here it's all infrastructure about quantization, preparation, and so on. So maybe it's more like Intel OpenVINA, Apple Core ML, and so on. So here it's like inference engine, which optimized for NPU, and say it's like C++, Python binding, and so on. You may think, okay, we have 3 level, but we need to use latest one. No, it's just a small part. Because also you have Gen AI SDK. It's a different SDK which you can use for run your LLM or VLM models, but you can't run this here. This SDK is specifically for mobile and their laptops processors. Okay, maybe it's whole? No, even for the each operation in the stack, you have different option. You can take your model from Model Zoo, or you can infer your model through the QAI hub. It's an independent repo of prepared model which you can run just with one Python command. It's like Hugging Face from Qualcomm. But you can work with just QAI RT and they own like examples. You think, okay, maybe that's all. No, when you're thinking about how can I quantize model for this board, you can run this model with IMET, which is the specific library to prepare your model, to quantize your model, to run your quantization aware training, or you can quantize your model after you already export model to the board with the QAI RT quantizer. And it's also totally different stack. And here it's like this everywhere. When I was reading even Radxa documentation, it's highlighting almost all that I told you right now. But if you go into the Qualcomm site, all this documentation will be much higher, and there will be much more documentation, and it will be much more complex. In my opinion, this complexity of the system, it's one of the main limitations of Qualcomm. You don't want to run some small project, you want to run with Qualcomm only the real big production projects. But you can run small project because right now all documentation is like released and you just can take it. Let's go through a few examples next of the code of how to run everything, and then we will go through the export, then we will move to this board specifically. So let's quickly discuss how to infer your neural network. So for neural network inference, you need this AI engine direct helping. It's basically forked by Radxa from original Qualcomm AI engine direct helper and optimized specifically for the chip, maybe not the latest version. For the inference, let's look on this sample PCI-ResNet 50 and check how it's working. As you can see, there is a lot of code. It's not as easy as it was for Rockchip and not as easy if it's for Intel, but basically everything here is more of or less understandable. In general, this app builder class, it's just wrapper around C++ libraries. Here are they, and it's just wrapped around them. And when you create in your code, you just need inherent from this class, and then you can inference. So basically it's pretty easy like this, but because this trick, it's not like super obvious. I don't know why did they do this, but it's a little bit more complex than for classical frameworks. But in my opinion, if they just will refactor this code, it will be a little bit more elegant. But I checked its work. It's easy to infer your own neural network here. And let's talk a little bit about quantization. And in my opinion, here everything is described quite nicely. I go through this guide and everything works. So basically you need to install everything on your host machine. Of course, it's like x86 host machine. There are a few problems in my opinion, because usually nowadays standard it's when you're providing already pre-built Docker image. And here you basically need to install everything by yourself. And it's a little bit strange. Sometimes there are some dependency warnings. Everything for me. And then you need like manually install correct frameworks which you want to utilize. For example, if you're working with NX files, you want to install this 3, if you're working with PyTorch, this, and there are no such libraries, for example, here. And this, in my opinion, a little bit strange. But it's like official, it's not like an Radxa idea, it's just official code from Qualcomm. In my opinion, it's like a little bit strange decision. So basically I used this guide. Everything worked well for me. I exported a few different neural networks, differs from this one. I worked with ONNX, but for me, not all neural network works. So basically for me, any 3D model didn't work, which is expected. And for me, even didn't work some half computer vision, half linguistic model, for example, YOLO World. But I mentioned a lot of mentioning that it should work with it. So maybe if it's quantized with IMNet, which is, I already mentioned what is it. It's this quantization tool, which is different from the base quantization tool from Qualcomm, then maybe it will work. I didn't try this, but it's like out of the box FP16 model for ONNX didn't prepare and export the model. And here it's like the second quantization approach, which I already mentioned earlier. Let's go through a few words specifically about this board from Radxa, finally. So, in my opinion, it's pretty interesting board. What I need to mention, first of all, of course, it's like Raspberry Pi format, but more than amount of connectors and interfaces is more than Raspberry Pi. For example, Radxa provided me eMMC UFC memory, UFC specifically in my case. It's worked quite pretty nice and fast. But of course, with this board, you have all like classical connectors that modern board have. From hardware perspective, everything I tested worked, but the software development is a little bit ongoing process. For example, initially it didn't run with NPU for me, and when I check official forum, they helped me to run this NPU. It's required additional command to initialize it, and only the latest version of the system will support it out of the box. And if you're looking on the forum, you can check that a lot of stuff, it's like ongoing process of fixing some issues, modernization, and it's pretty fast. When I received this board, it was third version of the system image, and now it's fifth version. So in my opinion, it's nice that they really take this board as one of their priorities. They fixing all these issues, and I hope that maybe even in 1 month everything will work. For the NPU stack, for AI stack, everything is working already, so I checked a lot, and right now there is no issues from this board perspective. In my article, you can check guide how to go to the first running neural network, but please be accurate, because even when I experimented with this board, this guide changed a few times. So look official documentation, but just keep in mind that it may be not full, packages that installed may be not full. Maybe you need to copy your SDK specifically on the address that was provided. And in my opinion, so when you start this board, at least for the moment right now, you need to understand what each command mean and just recheck the result. What the whole impression? And when we're looking on this board, it's really hard to distinguish Qualcomm impression and specifically this board impression. So I think I need to say it like this. Right now, Radxa provided a pretty nice board which you can use and experience all this Qualcomm around this board. All this big stack around, all this infrastructure, and so on. Right now, this board is super new and super hot, so you may have some issues from this board side, but in my opinion, they are pretty small and not significant. But when you will work with this board, starting when you installed all your Qualcomm SDK, your next impression will be more about this Qualcomm infrastructure than about this board. Because when you're working with AI, you're working with all this infrastructure. So this board is definitely great. And this board is also great experience because it's a different vendor than Qualcomm, directly Qualcomm related vendor who is providing this board. And it's actually showing a lot. And this board has a big potential. I don't know if Radxa will produce this board a lot and if they will focus this series. But in my opinion, from perspective of AI developer, it's a really interesting board. I hope that Qualcomm will create more edge devices, and maybe because they recently acquired Edge Impulse and Arduino, I hope this is their strategy. And if they will go deeper, definitely you need to use them for a lot of tasks. And definitely this Radxa board right now, it's a good starting board to have this experience in the next years. So, great board. Qualcomm specific system, maybe not something that you want to start from. Thank you for watching. I hope it was interesting. If you want some other videos about Qualcomm, about some specific of this Qualcomm stack, you just can ask, maybe I will release them. And also there will be pretty interesting Qualcomm ports on my channel in the next like few weeks or months. And I will return to you with different boards and different stories. Thank you for watching. Bye.